Vern Slater with Active Treatment Systems Inc., ATS Inc. He's going to come up and help us understand the chemistry of turbidity. So Vern, come on up. All right, Vern, you work with Active Treatment Systems Inc.
Yes.
And where's your office?
Located in Loomis, California.
Loomis. And what does ATS do?
We do active treatment system, go to construction sites, we'll treat stormwater runoff for turbidity and pH. Every once in a while there's an involvement of some of these other chemicals, and then we'll have to bring in some specialty medias and things to deal with those as well.
Okay, so people call you in when traditional BMPs like fiberroll, silk fence, hydromulch, hydroseed, when that's just not quite enough.
Right.
And usually they have a certain type of soil. And what kind of scenario, I guess, would make them want to call you or need to call you?
Colloidal clays, and long steep slopes are a lot of conditions that we see out there. Flatter sites, not necessarily as bad of a problem, but when those long steep slopes, and then you have that clay and colloidal clays.
Right. So when we run a Russell equation and we see that the number is going up because the K factor is pretty high, so meaning clays, right? Clays are going to have a high K factor, or the length of slope, steepness slope is pretty long slopes, steep slopes. So we're going to have a clue then that we may need some extra help because our A value in our Russell equation is really high. What other site dynamics might give us an indication that we may need an active treatment system?
Well, a lot of opened areas where they're going to have
a lot of disturbed soil.
A lot of disturbed soils, and in areas where the rainfall is going to be potentially 10-year, 24-hour averages are
heavy
very
volumes,
high.
Heavy volumes.
Yes.
And then probably storage, right?
Yes.
If you don't have a lot of room to store it, then you're going to need to get rid of it quicker.
Yes.
Okay. So when we talk about turbidity, in fact, right here we have I'll turn on the magnetic stir, get it going. But a very turbid, and you notice that even before I turned it on, it was still real cloudy. We had a lot of suspended solids in that water. But there's actually chemistry going on in that little beaker right there.
Yes, there is.
Can you explain to us what that is?
So what's going on here is you have a lot of small particles that are anionically charged. So they're repelling each other.
Okay, what's that mean, anionic?
It's a negative charge
All right.
on the particles, and so just like a magnet, you bring those negative ends close to each other, they repel.
Okay.
And that's what's going on in these jars.
Yeah, we have Mike Lewis in here. I've seen him in his office playing with magnets before. Just hours looking at that. Yeah. So like charges repel and opposites attract, right?
Right.
So the negative charges of the particles
and sometimes some small mass does not help either, because these particles are 0.2 microns and smaller. So they're so small they really want to stay suspended, but that negative charge is really fighting it.
So that's kind of like, I'll turn this off right now, but that's kind of what's happening right there then. It's on a maybe a very microscopic level. We got a magnetic stir happening.
Yes.
It's self-agitating then, right?
Yes.
Because if you got billions of these negative particles, they're just bouncing off each other like billiard balls, right?
Yes, they
and just
are.
staying in motion.
Yep.
So it's like our pond has got a magnetic stir happening.
Right.
And I understand that settling times for some of these clays is how long?
Oh, it can be even into hundreds of years.
Yeah, we just don't have that time to wait, do we?
47 hours. I think typically when I'm seeing on graphs, you're starting out at about 47 hours, and those are the products that we're attacking.
Okay.
They're really just not settling.
Right. So if you're blessed with a fortunate side of maybe sands or silty sands or fine sands, that might settle out pretty quickly, and,
Right.
and a holding pond or a tank might do the job for you. But otherwise, they're staying in solution longer than you probably have time to wait for it to settle out.
That is correct.
Okay, so the problem is what we call electrochemical problem. How does chemistry come into then solving that?
Okay, so we'll take a product like that's in this bottle known as chitosan acetate. It is a cationic charge, positive charged
Okay.
polymer. And it starts out in a tightly bound chain, but as soon as it starts hitting water of around 5 pH and higher, that bound chemical opens up into a long chain with a lot of positive attachment points.
Oh, okay.
So it can attract these negative particles into a big molecule that now will settle out,
So opposites attract. It's going to pull them together.
and they can also be filtered out.
Okay, so gravity can take over,
Yes.
and then they're bigger, and they won't blow right through a sand filter like clay would.
Right, that is correct.
Okay, well, good. Can we see how that might work?
Yeah, I think we can.
You
So,
brought in some supplies.
yeah, here's some water that was collected yesterday afternoon, and you can see it's been sitting all night, and it has a small layer of settled particles on the bottom. These are your larger particles that will settle out without too much help. But for the most part, this turbidity is going to be well over the 250 limit where
Yeah.
we could discharge. This was probably in the range of 1,000.
Yeah.
When it was mixed up, I took a turbidity reading and it was over 1,500.
Wow. In fact, our meter doesn't even go that high. It
Right,
only
and
goes
either
to
I had
1,000.
to dilute,
Oh.
and because my meter does it, it goes to 1,000.
And is that realistic of what you would see at a construction site?
Typically, I see between about 1,000 and 3,000 NTU on sites where an active treatment system is needed.
And just reminding everybody, the action level is 250. So we're 4 to 6 times higher than that.
Yes.
All right.
And so I'm going to shake this up a little bit here and just get all this suspended solids. This is as if the water was coming to you. This is how it's going to come. And it's going to come into a pre-treat system. And we would pre-treat with some chitosan. And chitosan, I might add, is from the construction general permit. You have to meet certain requirements for the polymer you can use.
Okay.
And chitosan is one of the only polymers in the state of California that can be used for treatment on construction sites
And why's that?
because of the residual test.
Oh, okay.
And we will see a residual test here in
Okay.
a bit.
Now, I hear different names. You said chitosan, you said polymer. I've heard flocculant.
Right. This particular material acts as a coagulant and a flocculant.
And what's the difference there, or what do those
Typically,
terms mean?
What's going on? So when you put in, I put in a single drop in here, you'll start to see some reaction going on, and that's the coagulation step. It won't really be enough to bring this water down to a treatment dirtiness. And so,
So when I think of coagulation, I think like a scab or
yeah.
something, right?
right, so
it's sticking it together. Is that what that means?
yeah, it's starting to stick it together.
Okay.
And then you add a little bit more chitosan, and now those smaller particles come together. They form the larger coherent mass, which are now your flocculation.
So that's
step.
called flock.
Yes.
So that's that bigger thing.
Yep.
Okay.
So I'm going to take up just a little bit in this little transfer pipette.
How much is that? About a milliliter?
That's a milliliter in there, but I'm not going to use
Let's see, 4, 5, 6 drops.
And I'm going to set this on your table.
Sure.
pH of 4. It's not terribly bad for you.
Well, and 6 drops in a quart.
And then I'm going to do some mixing. So normally with an active treatment system, there is a static mixer that does this. That can put more energy into this jar than I can if I stood here and shook it for probably
Now wait a
30
minute.
minutes.
You're not treating water mason jar by mason jar, are you?
No. So static mixers are the way we do it.
But that's for the bench testing. then is what you're referring to actually see what dosage you're going to
Yes.
use?
So I would do,
All right.
and typically use not a magnetic stir, but a stir plate that has 6 positions on it. And I can do multiple doses. I can do multiple polymers to really see how it works.
And you're doing something similar to what we're doing here, but that's just to figure out how much chitosan we need is optimal.
Right.
All right. But when it comes to treating the water, how are you introducing the chitosan?
So we use a liquid metering injection pump.
Okay.
And that has a calibration cylinder attached to it. So we'll do a jar test like we're doing now. We will come up with a parts per million of dose rate that's needed to treat this water.
Okay.
Then we'll use the calibrated cylinder, run a calculation, determine how many milliliters per minute to inject to reach that dose based on your flow, and then you start injecting.
And our water's not sitting in a mason jar, it's sitting in a pond or a tank or baker tanks or something like that. Okay.
Yeah, so as we can
All right,
see
wow,
in
it's
this,
already-
we've got a lot going on in there. It's cleared up pretty good. And then just to show you, time is our friend when it comes to treatment. So this is the same dirt. I treated it yesterday evening and just let it sit, and it only got stirred by driving down here.
Well, it doesn't look very stirred. Can we run a test?
Yes, you
We
can.
got a pipette. We could pipe it into here, right?
Yep.
In fact, I'll follow the instructions. Jonas said this is even idiot-proof, so I should be able to do it. All right, so we'll put some water in there. All right.
Sorry about getting that water on you
That's
there,
okay.
John.
We're going to wipe it off. Jonah showed us how to do this. I think we're pretty close. Yeah, we're up to the line. All right, it looks really clean to me, but in attachment F, which addresses active treatment systems in the general permit, the construction general permit, there's a different set of numbers, isn't there,
Yes.
than 250?
Yes.
What is that?
So once you become where you're using an active treatment system, you fall under a different set of rules on turbidity. You can discharge up to 20 NTUs on any single sample in a day, but you have to meet an average of 10 NTUs for that day. So this, I'm just guessing this water is down pretty low, a couple of NTUs.
Okay.
But we'll see right now, because the eyeball is hard to tell.
Yeah, yeah. Well, it says it's reading. So how often do you need to test the water as you're treating?
The general construction permit, I believe, requires 15 minutes after startup, and then every 8 hours during the day.
Okay.
Now, as operators, we test more often than that.
Okay, 4.72 is what it's saying.
4.72.
Is that acceptable?
That's very acceptable. I would still run it through filters because trapped in here is a little bit of chitosan that could be higher than what is allowed to be discharged.
Oh, now that is something that attachment F talks about. You mentioned residual chemical.
Yes.
That confuses a lot of people. I've noticed. It's like what chemical?
Right.
What chemical are we talking about?
Chitosan.
Chitosan. It's whatever we used, right?
Right.
So chitosan is not the only type of flocculant we could use. We could use something else, other chemicals.
Right, aluminum sulfate, polyaluminum chlorides could be used, but again, those don't necessarily have the residual test, so you're stuck operating in a batch mode.
Okay.
And which means you treat, hold, test, then discharge.
But we're not talking turbidity tests. We're talking what kind of test?
Bioassay, a 96-hour acute toxicity test.
So what some people call fish toxicity testing.
And for chitosan, the most sensitive species happens to be the rainbow trout.
Oh, so we're sending it to a specialty laboratory.
Yes.
They're subjecting our water to, or fish to our water, and if so many of them go belly up or grow a third head, then we have problems, right?
That is correct.
That's the idea. Okay, so the obvious place you want to be then is in the continuous.
Yes.
So you have this test that you can do within an hour, I believe?
Needs to be within test results come within an hour.
Yeah.
And the residual test usually gives results in like 15 minutes.
Okay. So, and the reason for that, I understand, is that when the State Water Board looked at this technology, I mean, obviously, I mean, you just look at this. It works. It really works. You really can get some clean water. But what they found, I understand, is that some of these chemicals can be very, very harmful to the receiving waters if there's too much left in.
Yes.
And what
there was a real popular polymer that came out early in active treatment systems called DADMAC. Very, very, very toxic. No residual test. And it used to be the premier product that was used. No more.
Yeah, it's too lethal.
The toxicity level of that stuff is way, way too low.
So there were fish kills associated
Yes.
with that, and although everybody wants clean water going downstream, having a bunch of dead fish is not desirable either.
Correct.
And so, although the technology is very promising, the water board saw it needed to have a certain level of control.
Yes, it did.
And so that involves this testing, but also somebody who knows what they're doing needs to do it.
Yes.
What are the prereqs for somebody who's going to do a system like this?
So we have to send them through an 8-hour class with a certificate. Testing procedures have to go on. They technically have to pass with a 70% or better. The state has not designated what they have to pass by, but our company, we've decided if you can't pass with 70% or better, you don't understand
So
the
it's
material.
8 hours in the classroom.
8 hours in the classroom, and then 32 more hours in the field with an operator.
On the job training.
On the job training, where you learn how to do the residual test, how to do your jar test, how to calculate that over to determine dose. All of those properties, they have to understand safety of handling the coagulants, the toxicity of the coagulant.
Yeah. Then if they're doing any of the field testing, they also have to be a QSP, right? And if they're doing turbidity or pH, they got to have that.
Actually, the active treatment system certification is all you need.
Oh, okay. All right. Well, good. So the problem is you can't eyeball it. Just as it's hard to eyeball turbidity, we can't go, no, there's no residual chemical in this.
Right.
Can you show us how you would test for a residual chemical?
Yes, I can. So, what I have here is some water samples collected. Now, this is coming from a good system that's operating well. One of these two is coming from a system that wasn't operating well, and the other one does.
Well, and they all look the same.
And they all look the same. So what we do is called a starch iodine test. We run, let me grab this box out.
Okay.
Move some things around.
And so this has got to be done in the field, or at least you have to be able to get your results back within an hour. And you're monitoring for other things too, pH and turbidity and flow continuously.
Yes.
A lot of those are continuously, and also with electronic monitoring.
It is
data logging.
required electronically every 15 minutes or sooner. And again, operators, we train them to do it every 15 minutes to back up that system.
Right.
So there's some reagents that we're going to use.
All right.
Okay, he's got some gloves here. So to keep from cross-contamination, wear a set of gloves. Because cross-contamination, I could have already and probably have touched chitosan. You know, if I'm handling the filters.
It doesn't take much.
Right, because
We
we're
saw
only
6 drops for that whole thing.
We're only looking for 10 parts per million or less.
Yeah.
And this particular polymer will go down, has been okay to be at 6.7 parts per million. It's a
Okay.
very, very small amount.
Yeah.
All right.
Let me know if you want me to help you with anything.
Okay.
So what is this you're putting in here?
So what I'm putting in is a glass fiber filter.
Okay.
And this is going to, what we're going to do is I'm going to add a color enhancement solution to each one of these. So I'm doing the same thing to all of them. Then on a spike, I'm purposely going to spike it to the minimum detection level of the polymer that we're searching for.
Okay.
Whoops.
And there's a written procedure for this.
Yes, there is. The manufacturer supplies that for you. I don't think I have a copy of it with me.
Well,
But
you
yes.
got this memorized.
Yes, I do.
You've done it a few times. All right, so we're putting in one of those glass filters in each one.
Yep, another glass fiber filter. Come on, get one there.
And you're being careful to use tweezers so that you don't.
Yeah, this is a double
contaminate it.
protection.
Yeah.
You know, I'm using tweezers. I'm using gloves.
All right.
Let's see, there's one. And the
one.
last one.
How long does it take you to do this if you don't have somebody interviewing you?
Again, it only takes about 15 minutes.
Each one?
Yeah, I'm not doing a third one. I'm only doing, because I collect one and I collect another one, so I'm only doing one.
So your standard will stay as your standard for some time?
Yes.
Oops.
That
Good
was
catch.
a good catch, wasn't it? Let's get that back on there. Make sure it's on right. Don't want no leak by.
All
Okay.
right.
So this one is for my spike. We got blank number 1 and we got blank number 2. Get these guys out of our way.
All right.
Okay, so color enhancement solution.
You want me to open this up?
Sure.
Okay.
Please do.
Open up each one.
Yep.
All right. And so it's color enhancement solution.
Yep. Technically, it's just chlorine, if
Okay.
anybody's interested.
Okay, so how many drops?
And 5 drops.
2, 3, 4, and 5. All right. All right, we're adding the color enhancement to it. What if I got an extra drop in one?
It's not going to make a whole lot of
Okay.
difference with the chlorine.
All right.
What really makes a difference is the spiking solution.
Oh,
you can't
yes.
mess this
Because
up.
that's going to be our standard. That's,
Yes.
That's our concentration, our control.
And you take a single drop of this stuff.
And what is this stuff?
This is chitosan acetate, but it's a very, very dilute solution compared to what is used in the field.
Okay.
This is just to get that minimum detection limit.
So 1 drop.
Yep, and so I'm just going to make sure drops are dropping well here before I go over there.
Okay. Very good. We got 1 in.
All right. And so there's that.
We need to shake that up.
Now we close all of these and shake them good.
All right, I'll get this one. I'll try not to mix them up.
Yeah, don't hit them into each other. We don't want broken glass and water everywhere.
That'd be exciting.
Although I know my guys break beakers in the field.
You know, we need a beat to go with this.
Yeah.
Maybe some salsa music. All right.
All right.
Is that good?
Yep, that is good. Now, we can take the lids off of these.
All right. Now what are you doing?
Now we're withdrawing, and I've got to get the bubbles out, so I squirted out the bubbles. And I'm pulling up 100 milliliters of the water sample.
Still got it. All right. There you go.
Okay. thread on the filter.
And then you can dump it in our sink.
Yes. And we'll start squirting this out. And you got to be careful not to push too hard because you can just blow a hole right through the filter and it will not collect.
Can I pull 100 mil?
Yes, sir, you can. Please do.
All right, so we're gonna draw it out, blow the bubbles out, and get 100 mils. Should I go a little beyond 100 and then push it back out?
I start out, I get a little bit and then push is there a lot of air bubble in it?
Only a very little one.
Okay, that shouldn't be too bad then.
All right, right at 100 here.
All right.
And then I put this on,
Yep, and thread that on.
like this.
Nope.
This
There
way.
you go. And be careful when you're threading that on that you don't unthread this bottom part.
Okay. And then push it out,
Yep, right in there. Very carefully, not too fast.
because you can blow it out, right?
Yes.
So is this going to count as my ATS training?
Sure.
Only 7 hours and 45 more minutes to go, right? All right. We're almost done here. How about I blow those bubbles out, or blow that water out
Okay.
too? There you go.
You get that. I'm going to get something to put our filters in.
This feels like a real chemistry lab. All right. So now what are we doing?
Now I'm just getting something that is not paper to put the filter into because the paper will react with the iodine just as the chitosan would and give us a false positive.
All right. I'll let you move over here.
All right. So I'm going to take the spike off that we purposely spiked to the minimum detection level.
Okay, so you took the papers out, you put them in these little trays, and once you get done, we'll set them out here so everybody can see them. Again, using your tweezers, being real careful not to cross-contaminate. All right. Well, let's move these trays up front so people can see them. Are you got to do anything else to them?
Now I have to add iodine.
All right.
And
this
what
one
did
right here?
There we go. There's my iodine.
So iodine. So I've heard this test called an iodine starch test.
Yes, it is a starch iodine test. The chitosan is technically a starch.
Okay.
It does biodegrade.
All right. And the iodine is our colorant. Is that what is happening?
Yep. It's giving us a reaction.
And it's reacting with the starch.
Yes.
So what's our objective here?
So our objective is to see the different colors. So you see how this pattern is developed here?
Uh-huh.
This is in our bad water, number 2.
Yep.
Number 1, notice we don't have any pattern at all.
In fact, let's hold these up. So here's number 1. Let's see if we can get this a better angle here. Here's number 2. And you
then
got
number
the
3,
control.
my
That was
control
the
spike.
control.
Yep.
So what's this telling us?
This is telling us that these two are probably, this is showing you that this one has too much chitosan in the residual.
Because it's as dark, if not darker, than this one.
Right.
And this one's clearly lighter.
Clearly lighter, and as we let these sit over an hour, the iodine will completely evaporate off of that and leave that white, and these will have a bit of a purplish color left over.
Oh, okay. All right.
So if you're
Great.
a little unsure, people have had a hard time doing these residual tests before. Colorblind people really struggle with it. But letting them dry a little bit, and then you'll see that purple color.
All right. Well, Vern, I really appreciate you coming out, because I think a lot of people don't understand how much chemistry actually goes into just dealing with turbidity and then active treatment systems. I've learned it's all about chemistry. So thank you for coming
very
out.
welcome.
Now, let's say somebody wants to learn a little bit more about how they could bring an active treatment system to their site.
Right.
You got a website or something?
Yeah, the www.ats-env.com.
So ats-env.com.
Yes.
All right, and they can look up your phone number and give you a call and
Yes, they
talk
can.
about the chemistry of their site. Well, thank you again for
You're
coming.
welcome.
All